Okay, my name is Hunter Bergeron, and today I will be going over my testing system for 403. The testing system I will be covering is for a cooling system. All right, so my customer I'm using as my example is Dan's Excavating Incorporated. Dan's is a larger company. They own multiple pieces of equipment of multiple makes and models. They usually take on larger jobs, but will also do a number of smaller jobs like trucking and sand and gravel transportation. The piece of equipment that I am going to be covering today is a John Deere 650J LGP cabbed crawler dozer. The machine was made in 2006 and has about 4,500 hours on it. So the complaint that is getting fixed is a faulty engine cooling system. Whenever anyone tries to operate the machine will overheat after a short period of time, usually after a couple of minutes. If the machine is shut down and given a little bit of time to cool down, it can be operated again, but only for a short period of time. The machine worked fine the last time it was operated, and then when the operators all left for the weekend break, they left the machine on the job site. And when they finally returned from their break on Monday and tried to start the job back up again and start the machine and move it, they found the problem is now starting to occur. So after speaking with the customer, they said that they had already replaced the thermostat in an attempt to just try and get a quick fix so that they could get their machine back up and running. But they said that even after replacing the thermostat, the problem is still there and it's still overheating just like it used to. They said that they need the machine back up and running as soon as possible. They also mentioned that cost is not a major factor when it comes to repairing this machine. So after speaking with the customer, I proposed that we take the machine and have it shipped to the shop. And then from there, once it reaches the shop, different tests will be performed on the cooling system to determine what's wrong. So the complete timeline for the machine is as follows. Initially, when the machine gets into the shop, obviously check all your fluids, check your coolant, of course, is the most important, but also check engine oil, make sure that there's no oil in the coolant, no coolant in the oil. That will raise a number of problems from there. And then also tracking the machine around to make sure that the operators aren't just doing something wrong, that it is overheating, and that there is actually a problem with the cooling system. From there, I'm going to use a thermal imager to read the different parts of the cooling system, try and see where heat isn't being exchanged, where heat might be building up. After going through the entire machine, it is seen that the radiator is not properly exchanging heat and that there are hot spots in the radiator. From the thermal image, it looks like the radiator is blocked. So from there, we're going to unhook everything and start to flush the cooling system and flush the radiator itself. After flushing it, found debris, a little bit of dirt, and a couple handfuls of smaller stones. After finding the debris, I'm gonna remove the water pump and inspect the water pump, see if there's any damage, see if the water pump needs to be replaced. After inspecting the water pump, it's found that the water pump has no damage and can be reused again. So from there, after flushing it and inspecting the water pump, going to refill the cooling system and then try to operate it again to verify that the machine has been fixed. So after refilling it and running the machine around, find that the problem is still there. It's not as bad. It takes a little longer for it to overheat, but it still does overheat after a while of operation, and definitely when the machine is under load. So after finding that the problem is still there, you're going to scan the radiator again with the thermal imager, and there's still a couple of passages that are blocked and not allowing the radiator to operate at maximum efficiency. Stones are obviously really lodged in the cooling passages, so the next step is to order a new radiator and slap the new radiator in so this machine can be back up and running as soon as possible. After the new radiator is installed, operate the machine, refill the cooling system obviously, but operate the machine one more time, make sure that everything's running the way it should be. And once we do that, we find the machine has now keeping the proper operating temperature for the engine and is working as it should. So the special tools that were used for this testing system was a Fluke TI-10 9Hz thermal imager. Like I said, the thermal imager was used to scan the radiator and scan multiple parts, and then we finally ended up at the radiator to see that the radiator is blocked and that coolant flow is not going through at 100%. So like I said, the cause, vandals poured dirt and stones into the radiator, and the stones then went through the radiator and lodged themselves into the cooling passages, which keep the coolant from flowing through. All right, so to correct the issue, like I said, the cooling system is flushed and then debris is found. We inspected the water pump and no damage was found, so the water pump could be reused. Then the cooling system is reassembled once more and it still didn't operate like it should. And then the radiator is removed and replaced with a brand new one, and then the machine works as it should. So after the machine is tested, flushed, tested again, and a new radiator installed and then tested once more, the total labor comes out to 1 hour in diagnosing and recreating the problem and checking your fluid levels and such. 3 hours into initially removing the cooling lines and flushing the whole system and making sure that everything's out, and then hooking back everything up and then testing again. And then 2 hours go into pulling the old radiator out and putting a new one in and refilling the cooling system. Okay, so finally for cost, with this being a simple, straightforward job that only needed one man to work on, didn't need any help. The total cost comes out to $1,260. $660 on 6 hours of labor, $140 spent on 10 gallons of coolant, and then finally $460 spent on a new radiator. Once the machine was shipped back out to the customer and follow-up conversation was had with the customer, the customer said that they might know who the vandals were, that a few operators had to be let go of in the last month due to them either messing up or just not doing what they're supposed to and costing the company more money than they were making them. So they were let go of, and this could possibly be an act of revenge, and those operators will now be questioned. All right, that concludes my presentation. Thank you for listening.